Okay, so the topic of this video today is some of the basics about the immune system. You can see three examples of reasons why we need to understand our immune system. On the left is the bacteria that causes tuberculosis. In the top right is the fungus that causes athlete's foot. And in the bottom right is probably one of the most devastating viruses of all time, the influenza virus. It causes the flu. So let's go ahead and get started looking at our immune system. Okay, so you might know that our immune system helps fight off pathogens, and just in general, pathogens are typically microorganisms that cause disease. And let's break it down into a few categories, pathogens into a few categories. Viruses. Later on in the year, we'll learn more specifics about viruses, but for now, just want you to know that viruses will actually turn your cells into basically virus-making factories, ultimately ending in the death of your cells. We'll study viruses in more detail in another chapter. So another type of pathogen would be bacteria. Now remember that bacteria are prokaryotic cells. They lack a nucleus, but what makes bacteria pathogenic is that many of them will release toxic chemicals. And when those toxic chemicals build up and build up and build up over time, they can cause various sicknesses. The picture you see here is the bacteria that causes the disease tuberculosis. If we look at this x-ray of a person's chest, this person has tuberculosis. And so look at the left side of the picture. The lung on the left side of the picture looks black, and that's good because it's filled up with basically air. But look at the lung on the right side of the picture. Now, even though it's the right side of the picture, this is actually the person's left lung. But notice it looks different. It's not filled up with black air. It's got this cloudy white area. That's because this lung on the right side of the picture is filled up with mucus and pus and phlegm. It's a sign that the person is very sick with tuberculosis. And let's see, here's a fungus. Fungus are another type of pathogen, and when fungal cells feed, let's say they're growing on dead leaves. Well, when fungus cells feed, they will pierce the cells of the dead leaves and absorb the nutrients that are in the dead leaves. Now, that's fine and dandy if the leaves are dead and the cells are dead, but some fungi can be parasites and will actually feed on living cells. So the fungus in the picture, this is the fungus that causes athlete's foot. You can see this picture of in between a person's toes. The skin is all cracked and dry. Well, the fungus that is living in this person's foot cells is pierced the cells and is absorbing the nutrients from the inside of the cells. Causes a very itchy, burning, painful sensation. The good news is there are various topical creams and sprays that can treat athlete's foot and ultimately kill the fungus. Another type of pathogen are what are called protozoans. These are single cell, and how are they different from bacteria then? Because bacteria are single cell. Well, protozoans are eukaryotes, and bacteria are prokaryotes. So protozoans are single cell eukaryotes. So in the picture here, these purple shaped protozoans, this is again highly magnified right here in this picture, but these purple protozoans are a type of protozoan by the name of Plasmodium. And this Plasmodium parasite causes malaria. And you can see here from the table just some of the signs and symptoms of malaria. And in areas of the world where malaria is more common, you can see this map right here, the red areas show where malaria is more of a threat. You can see it's more of a threat in tropical areas of the world. But even though we may not have a big malaria threat here in the USA, for those of you who might travel to tropical areas, this could be a concern. And then there's just the parasites in general. And so here's a tapeworm egg. You may have heard of tapeworms. Well, here's a tapeworm egg, and you might accidentally ingest this, perhaps in meat that's not cooked properly, cooked thoroughly. And so you might ingest the tapeworm egg. Well, over time, that egg is going to grow into a tapeworm, and the tapeworm is probably hanging out inside of your intestines. And so here's a drawing of, at the top of the drawing is the head of the tapeworm. The head is called a scolex, by the way. Well, let's zoom on in. When we zoom on in, here's a real neat picture of the head or the scolex of a tapeworm. You notice it's got those hooks on top. Well, those hooks actually anchor the tapeworm into your intestinal lining, into your muscles. You can see the suckers. The suckers also help to anchor wherever they are living. And so tapeworms are another example of a parasite. Well, our immune system is designed to help keep us healthy from all of these examples of pathogens here. Not just tapeworms, but all the ones on the list. And so how are pathogens typically transmitted? Well, and it really depends on the pathogen. I'm sure you know examples of some that might be carried by water, by wind, direct contact and indirect contact. Look at our gentleman on the left. Achoo, and he sneezes some viruses out. You know, the lady on the right was never in direct contact with that guy, but she may have inhaled some of those viruses that the gentleman on the left sneezed. So, you know, you may have indirect contact with a person who has a sickness. Some of you may have direct contact. You know, for instance, if one of these wrestlers has a fungal rash, a fungal infection on their skin, you know, just in the activity of a wrestling match, you know, there's some direct bodily contact that could possibly spread a fungus infection. You know, two of the dirtier things actually that you touch on a daily basis, two things that you come into direct contact with on a daily basis would be doorknobs and cell phones. You know, when's the last time you cleaned the doorknobs in your house? You know, when's the last time you got a rag, sprayed some Lysol on the rag and wiped down every doorknob in your house? I mean, who does that? Chances are you haven't done that ever. You know, if you ever do clean your cell phone, same thing. You may spray some cleaner on a rag and wipe down your cell phone, but how often do you truly do that? So when we focus on how pathogens are spread, pathogens are many times spread by objects called vectors. And we'll go over some examples. You know, the first one, let's focus on the disease called malaria. We saw this picture a few moments ago. In the picture is the Plasmodium organism that causes the disease malaria. But the vector of malaria you might know to be mosquitoes. So if a mosquito is infected with this Plasmodium parasite and the mosquito bites a person, good chance that the mosquito will inject that Plasmodium into the person. And so one thing I want to clarify is that the species of mosquito that spreads malaria, you know, mosquitoes don't cause malaria. Mosquitoes can spread the parasite that causes malaria. So there's a little distinction there I really wanted to stress. Mosquitoes don't cause malaria. Malaria is caused by the Plasmodium. It's just that mosquitoes can spread the Plasmodium. The bubonic plague you may have heard of, you know, it killed 50% of Europe a couple hundred years ago. Here's a picture of the cause of the bubonic plague, a bacteria by the name of Yersinia pestis. This bacteria right here caused and still causes bubonic plague. This bacteria is still around today. But it's spread by fleas. So you may have heard from history class that fleas caused the bubonic plague. Well, that's not entirely true. I mean, fleas spread the bacteria which caused the bubonic plague. And this last one right here, here's a person's hand with Rocky Mountain spotted fever. Now, the cause of that rash that you just saw is a bacteria by the name of Rickettsia. I think I said that wrong, but this is the bacteria that causes Rocky Mountain spotted fever. The vector would be ticks. So ticks don't cause Rocky Mountain spotted fever. If a tick bites you, it might transfer the bacteria called Rickettsia to you, and that's what causes Rocky Mountain spotted fever. Okay, so now let's actually look at the parts of your immune system. You know, it really does begin with your skin. Your skin is often called your first line of defense of your immune system because it's a physical barrier. There are various layers to skin to help keep out foreign pathogens. And so not only are there various layers to our skin to keep out pathogens, but our skin also produces oils and sweat, which can actually help destroy and kill various pathogens. So here's a little animation of your skin. And the notes say that some pathogens will burst and some will shrivel. Well, here's a bacteria that just landed on your skin, and pretend that your skin's really oily right now. And so skin oils will actually weaken the cell membrane of the bacteria and cause it to burst. Well, here's another bacteria that just landed on your skin. Let's say your skin is really salty right now because maybe you've been sweating a bunch. And so salt, you might know, dehydrates cells and causes this particular bacteria cell to shrivel. Either way, both examples, the bacteria that landed on the skin died. And so a great example of how our skin can be a first line of defense. Well, as we look past our skin, there's all these openings to our skin. And bacteria and viruses and fungus, they can gain entrance to the body through these various openings. Well, our openings are surrounded by what is called a mucous membrane. So the mucous membrane coats the openings and the exit of the human body. And so you think about, where are all these openings and exits of the human body? The nose, mouth, ears, eyes, genitals, anus. So we have a layer of mucous membranes that coats and surrounds all these areas of the body. And so you look at, here's a list of items that are commonly inhaled. And in my animation, here's a person that just inhaled those 3 black dots, and pretend the one on top is a fungus, the one in the middle is a bacteria, and the one on the bottom is a virus. There's a good chance that these 3 pathogens will get stuck in the sticky coating of the mucous membranes. And so they'll never get past and actually gain access into the internal cells of your body, because our mucous membranes are lined with a sticky fluid to trap the pathogens. They're also lined with cilia, cell parts that wave back and forth, and ultimately will lead to you maybe sneezing the pathogens out, or you could actually even swallow them into your stomach acids of your stomach, and then they'd be destroyed. But the point is that often they'll get trapped in the sticky lining of the mucous membrane and not really go any further. Well, what happens if viruses do gain access to the internal parts of our body? We have defense proteins to help fight these various pathogens. So one form of a defense protein is called an antibody. Antibodies are created and released by a kind of a cell called a lymphocyte. And here's an actual picture of a lymphocyte, and we'll talk more about lymphocytes throughout this video. But an analogy I'd like to make is that antibodies kind of act like handcuffs. They're going to attach themselves to a foreign invader. And when we look at these cute little cartoons here of a couple of viruses, notice how there's these little bumps on the outside of a virus. Well, these little objects on the outside of a virus are called antigens, and they exist on the outside of bacteria as well. And what happens is our lymphocyte will produce these little handcuff objects called antibodies. Those antibodies will attach to those antigens, kind of acts like handcuffs, and that way the viruses will be controlled and locked into place so they can eventually be destroyed by other cells of the body. So you're often going to see antibodies in textbooks, in this video, just kind of shown to look like a letter Y. And the reason for that is in the picture on the left. Antibodies are proteins. They're actually in the shape of a letter Y. The picture on the left is a fairly realistic shape drawing of what antibodies look like. So how do they actually kill? Well, in my animation, there are these Y-shaped molecules called antibodies traveling through our blood. And notice the black and yellow one, the one that's flashing. It just attached to an antigen of the virus on the top. My notes say that antibodies will cause pathogens to clump. So the antibodies will actually cause those 2 viruses to clump together. The antibody is actually holding on to those 2 viruses like handcuffs. So they're really trapped. They can't spread. They can't get away. Now that they're trapped and being held down by the antibodies, you have white blood cells called phagocytes that kind of resemble my Pac-Man animation up here. And white blood cell phagocytes will simply devour the entire cluster. And so that's one way that antibodies kill. They hold on to and trap the pathogens until they can be devoured by white blood cell phagocytes. Another way that antibodies will fight infection is they will actually weaken the cell membrane of the pathogen. So here's a bacterium that's in your blood, and notice how a bunch of antibodies are attaching to the bacterium, poking little holes in the cell membrane of the bacteria, eventually causing the bacteria to burst. So there's another great way that antibodies can actually destroy foreign invaders. Another type of defense protein I want to mention is called interferon. Well, here's two cells, but watch what happens. The cell on the left has just become infected with a virus. The virus has injected its RNA and new viruses are being created. Sadly, the cell on the left is infected and it's gonna die. There's really no way to save it. So step 2 of this process, the cell on the left is going to release a defense protein by the name of interferon. Now in the word interferon, I hope you can see the word interfere. So clearly this interferon is going to interfere with something. So the infected cell releases interferon, and notice the healthy cell on the right received the interferon. The healthy cell on the right is then going to begin to create defense enzymes, illustrated by my animated scissors here. So the animated scissors are representing the defense enzymes created as a result of receiving interferon. And unfortunately, the cell on the left is going to be destroyed, but the healthy cell on the right is going to be able to fight the virus now. So watch this. Our infected cell, the infected cell was just destroyed. And as those new viruses try to infect the cell to the right, the defense enzymes, the animated scissors, are destroying the new viruses. It helps to keep the cell on the right healthy and not become infected. That's kind of just a neat little animation of what interferon can do. All right, so I'm sure you've heard of types of cells called white blood cells. And in the picture, there's a red blood cell on the left, and then there's a cell in the middle and a cell on the right. The cell in the middle and the cell on the right are different kinds of white blood cells. And in general, the job of white blood cells are to search and destroy. Now there's various kinds of white blood cells, so let's mention a few of them. So one of the types of white blood cells I want to mention are what are called phagocytes. And like the notes say, they surround and engulf invaders through the process of phagocytosis. You know, there's a virus right in the middle of our blood vein. And here comes a white blood cell phagocyte. And through the process of phagocytosis, that phagocyte's going to begin to surround and devour that virus. And notice how the virus is trapped. It's trapped inside of a lysosome, but it's still alive. Well, what's kind of neat is that digestive E for enzymes will be placed inside the lysosome, and ultimately that will destroy the virus. So that's one way that phagocytes help patrol our body and prevent us from becoming sick. Here's a real neat thing, neat skill that phagocytes have. Let's say that you're walking home from school one day and you don't see that rusty nail sticking out of a fence, and you accidentally brush your shoulder against it and you cut your skin. Well, that can now be a way for maybe bacteria to enter your skin. Well, watch this. White blood cell phagocytes actually have the ability to squeeze out of your bloodstream, crawl over to where the bacteria is, devour it through phagocytosis. So white blood cells don't have to just stay in your blood. They can actually exit your blood, crawl to where the invader is, and destroy it. A second type of white blood cell I want to mention are what are called lymphocytes. Now there's two different kinds of lymphocytes I want to briefly mention. One of them are called B cell lymphocytes, and shown by the letter B right here. Now B cell lymphocytes are not actually shaped like the letter B. They're called B cells because they mature in your bone marrow. But I just wanted to animate and illustrate them as the letter B for a B cell. And they're creating these Y-shaped proteins called antibodies. And watch the antibody that's flashing. So the B cell is going to release a bunch of antibodies, but again, the flashing antibody has attached to an antigen to the virus on the left. That will cause the two viruses to clump together. Remember that antibodies kind of act like handcuffs. And so now that these two viruses are clumped together, a phagocyte will come and devour the whole group through phagocytosis. So there's a benefit of what B cell lymphocytes do. So the other type of lymphocyte I want to mention are what are called T cell lymphocytes. Now, T cells, you see, they're traveling in our blood. Now, they do not actually resemble the letter T. I'm just being symbolic of a T cell. They're called T cells because they mature in your thymus. It's a gland called your thymus. And so what T cells do is they destroy any cells that may have become infected. So let me show you what I mean. Here's two red blood cells. You have a healthy red blood cell on the left, but you have an infected red blood cell on the right. And notice how the infected red blood cell on the right, there's antigens of the parasite. There's antigens of the invader sticking out of the red blood cell. That's actually very realistic of what happens in real life. So T cells will, travel through your blood, and if they encounter a healthy red blood cell, there's no antigens of the invader sticking out of it, so there's no reason to attack. The T cell moves on. And now the T cells come to the infected red blood cell. Remember, the infected red blood cell has antigens of the attacker sticking out of it. Well, the T cell will see those antigens and it will release a bunch of E for enzymes onto the infected red blood cell. Sadly, it's going to kill your own body cell, but it will also kill the infected, it'll kill the infection, the pathogen that was causing the infection as well. The T cell then moves on and continues. So as I wrap up this video, I want to mention what a vaccination is. First of all, a vaccination is designed to prevent you from getting sick in the first place. It's not designed to cure you if you become sick. So the newspaper clippings are from 1955. The gentleman in the picture created a vaccine for polio. Polio is a virus infection where sadly people who are infected with this particular virus, the virus destroys cells of the nervous system and ultimately can lead to paralysis and eventually death. Well, when we look at what the vaccination process is, here we see a young man, a young child being injected with a vaccine. Some vaccines are injected, some are pills, some are even eye drops. And so a weakened pathogen is being injected into this little boy. And so in our little cartoon here, we're going to inject this little kid with a vaccination. We're going to inject them with a weakened version of a virus, perhaps. And now that we've done that, the immune system is going to produce a couple things. Let's zoom on into this kid's arm and see what's going on at the cellular level. So now that we've zoomed on into the kid, we can see that we've injected this kid with a bunch of dead viruses. Now they're dead, so they're not going to hurt the kid, but our immune system doesn't know that they're dead. Our immune system is going to see these foreign invaders and think that it needs to attack. So what's going to happen is that there's a B cell. Remember what B cells make? They make antibodies. There's a B cell and it's going to make a bunch of antibodies and it's going to release these antibodies into your blood. And even though the viruses are already dead, they're going to be destroyed even further. So now we have antibodies, more antibodies in our blood to fight infection. A second thing that's going to happen is memory cells are going to be made for future infections. Those B cells that were made are going to multiply, and those memory B cells are going to multiply, and so this makes basically a reserve group of B cells should you ever encounter the real virus. And so the goal is to make these memory cells, and the goal is to make these antibodies and depending on the vaccination, some of these memory cells and antibodies you'll keep for life, depending on the vaccination. Others, you might need a booster maybe every 10 or 20 years. But the purpose is, let's say 30 years go by. What happens if you were to recatch, not the dead virus, but if you were to recatch the living virus? Well, the good news is you already have antibodies, you already have memory cells that were created 30 years ago when you were vaccinated that will hopefully recognize that living virus and attack it. So there you go. There's a real brief introduction on the immune system. Go ahead and pause this video, especially if you're in my class, and put your answers on a separate sheet of paper. I'd love to check them before school or after school for accuracy. Good luck.